Hello team and welcome! As some of you may know, my name is Elissa. I wanted to introduce this new project to you. It's called Smart Urban Forest Strategy and it aims to improve the current urban forest renewal project in Melbourne. Smart trees, eco-cities, leveraging AI to nourish Melbourne's urban forests daily. We aim to significantly improve the frequency of data collection and analysis, preserve workers' time and energy through tree health and maintenance AI and ML diagnostics, and automated precision watering with alert systems. We also aim to visualize data in insightful dashboards. The project stakeholders include the Melbourne Mayor Nicholas Rees, arborists, the tree maintenance team, biologists, myself as the product owner, the Scrum Master and the Scrum team, which we will be seeing shortly, precinct maintenance managers, drone pilots, developers, vendors and technicians, council workers, the treasurer of the City Council, the finance team and the public. The Melbourne Mayor provides political project support to achieve the original project's goals, including increased canopy coverage and soil moisture and better tree health supported through biodiversity. The Mayor also promotes the project vision to the community, tourists and major external organisations, including the University of Melbourne. Arborists will be notified of sick trees and their diagnosis, visit them and create treatment plans. The tree maintenance team executes the treatment plans, maintains trees away from infrastructure including the road and power lines, and prunes tree branches for better growth. Based on the data collected, the drones notify the maintenance team regarding which trees require maintenance, enabling their targeted intervention. Drone pilots will fly drones that collect tree health and maintenance data and water dehydrated soil. Software developers and data analysts will take the data collected from drones to visualize them in Power BI dashboards to share with all the internal stakeholders. The City Council workers will receive and occasionally respond to the pre-existing tree emails from the public to keep stakeholders entertained. Similarly, they will undertake any administrative work in the project, including organising new trees to be planted. The Treasurer of the City Council is the project sponsor and thus responsible for the Council's finances. Therefore, all new project ideas must be explained to and approved by the Treasurer. The finance team is responsible for intricate financial planning, budgeting and handling payrolls for all workers. The data from the Power BI dashboards enable the financial team to undertake budget calculations more efficiently, as they can, for instance, anticipate how many new trees need to be planted. Drone vendors sell the drones for our usage and benefit from receiving funds for the sale. Similarly, the drone developers will benefit from the job opportunity to be a part of an innovative project. Two of the main project management methodologies are Waterfall and Agile, including Agile Scrum. The Waterfall approach upholds a linear methodology where each task must be completed before the next one can begin. Waterfall involves heavy planning and is therefore quite rigid, with the project delivering products at the end. In contrast, Agile Scrum relies less on upfront planning and focuses on completing finished segments of the project in iterations. The project has selected an Agile Scrum methodology. Scrum offers increments of faster product delivery than Waterfall, which enables the team to begin using the first completed project section. As a result, the project can fulfill its aim of enabling the Melbourne Urban Forest Renewal Project to reach their goals faster. Since the Urban Forest Strategy is an ongoing project, the users should be able to use the system as soon as possible. Therefore, Agile is the most suitable methodology for the project, as we can deliver items faster, component by component. Scrum also empowers the project to receive regular customer feedback during its development, which enables the project to have higher quality value in the end. The diagram here showcases the Agile Scrum methodology. The product goal is essentially the goal of the project. It guides the product backlog items. The product backlog is a list of all the work that must be completed to accomplish the entire project. The product backlog is broken into user stories, which are explanations of a software feature, usually written in the perspective of an end user. User stories can be further broken down into tasks, which are smaller, detailed pieces of work that all together complete the user story. Sprint planning is the process when the Scrum team chooses one or more product backlog items and plans how they can be completed within a sprint. The list of work items are known as the sprint backlog. A sprint is a 1 to 4 week period where the specified product backlog, user stories, and tasks aim to be accomplished. We selected 3 weeks for our project based on estimating the workload. Now, it's important not to overload the allocated work in a sprint, as we should aim to finish them on time and so that they meet predefined quality standards. Similarly, a sprint goal is the aim or objective of a sprint. The Scrum team is a small group of 3 to 9 developers, as well as the Scrum Master and Product Owner. The Product Owner highlights the product's vision and goal and manages the product backlog. The Scrum Master is the servant leader, as they serve the team to help them succeed. They facilitate the Scrum methodology and Agile principle implementation as well. All team members are equal, self-managing, and have cross-functional skills, which might be different from more traditional project management methodologies that you could be used to. Now, the daily Scrum is a 15-minute meeting for the team's developers to examine if they are on track to achieve the sprint goal and manage the sprint backlog accordingly. An increment is a usable piece of product that has resulted from the sprint and partially contributes to the completed project. Furthermore, the definition of done is the criteria that the increment must meet to be considered fully completed. The sprint review consists of the Scrum team and end users inspecting the increment, so that the product owner can modify the product backlog to incorporate any improvements. Modifying the product backlog is known as product backlog refinement. Similarly, the sprint retrospective consists of the team discussing what aspects of the sprint went positively, where improvements could be made, and what they will do in the future to improve the next sprint. Now, you already know about the product owner and Scrum Master roles, but let me tell you what the rest of you will be doing. The drone developer configures the drone operating systems. Drones uphold real-time operating systems, including PX4 Autopilot, which is used for flight control. The project also requires a software developer and data analyst with Python and Power BI expertise to acquire the drone sensor data and build the Power BI dashboards. An automation engineer will configure drone sensors for canopy cover, tree health, and soil moisture. The drone pilot and quality assurance engineer will test the drones to ensure they meet the quality standards. Now, the drone pilot will also navigate the drones daily in case they need to manually intervene. The arborist and tree maintenance worker will validate data accuracy and determine if the data collected by drones is useful for their job role. An arborist and precinct maintenance worker undertake functional testing, you can say. Now, the drone technician repairs and maintains drones. The project's scope is to harness specialised drones to provide a more efficient method to enable the Melbourne Urban Forest Strategy to reach its goals. The drones will deliver RGB and multispectral cameras for tree health monitoring, Internet of Things sensors to record soil moisture and canopy size, and water dehydrated soil with a precision watering system. The drones will automatically alert the tree maintenance team with the locations for trees that could not be hydrated due to the water completely emptying. Further deliverables include AI and machine learning for data capturing and analysis, and detecting ill trees. The drones will scan each tree, comparing visible symptoms with hundreds of diseased tree images in a database to determine and diagnose an infection. The drones will use the multispectral cameras, which see electromagnetic wavelengths beyond the human eye, to diagnose ill trees before symptoms appear, enabling the council to undertake advanced precautionary measures. For instance, the electromagnetic spectrum cameras detect low leaf reflectance, which can reveal low chlorophyll levels. The low chlorophyll levels indicate that the tree suffers from nutrient deficiencies or an illness. The drones send a CSV file to the council regarding dry soil, diseased trees, and maintenance requests. Therefore, the drones reduce the time the tree maintenance team takes to monitor the trees weekly and instead enable daily, ongoing monitoring. The tree maintenance team and arborists will only intervene when the drones flag an issue. However, the project does not eliminate the need for treatment plans established by the arborists and executed by the tree maintenance team. Also, the tree maintenance team must still respond to drone data to maintain the trees, such as trimming and pruning. The drones will not undertake any maintenance processes other than precision watering until the water completely empties each day. The deliverables are the drone-based data collector, AI and ML diagnostics, automated watering and alert system, and the Power BI dashboards and visual analytics. The DDC and AMD will be released in the first version before the AWA and PDV are released in the second version. Regarding the product structure, the DDC acquires data in the project. It consists of drone operating system configuration, Linux, PX4 Autopilot, and drone deploy to capture canopy cover, soil moisture, and tree health data using RGB and multispectral cameras and IoT sensors. The drones will follow pre-mapped automated flight paths for each precinct, enabling consistent coverage. The drones will uphold manual override options for drone pilots to ensure drone and public safety. The data collected is sent to the software engineers and data analysts in a CSV file. The CSV file data will then be used for AI and ML diagnostic analysis and PDV. Regarding AMD, drones use AI and ML to compare scan tree images to a database of hundreds of sick tree images for disease detection and diagnosis. Now, the AI and ML diagnostics were configured in DDC. AMD data will accompany AWA data when being sent for PDV, as you can see in the diagram. The diagram also displays more details on the types of data collected. Regarding AWA, the drones will use multispectral cameras to determine leaf and soil dryness. If a soil temperature of 39 degrees Celsius or more is detected, then automatic precision watering will occur. When the water finishes, drones will send an automatic alert to the tree maintenance team requesting manual watering at specific locations. All hydration-related data collection was configured in the DDC stage. The data complements the AMD data and will be sent to the software engineer and data analyst for PDV as well. Now, regarding PDV, AMD and AWA data captured from the drones, enabled from the initial DDC configuration, will be used for PDV. The Power BI dashboards will be shared with all internal stakeholders. After the initial dashboard is established, the drone CSV data will automatically update the dashboard visualizations after data is collected. The data analysts can then spend time visualizing, analyzing, and reporting other data, enabling greater insights to be found. The main priority is the DDC, as it foundationally configures the drones to collect data from the trees. Accurate DDC triggers the AWA. The AI and ML diagnostics can accurately analyze the data for tree diagnosis before PDV can occur. Configuring the drone operating system is a foundational user story item which must occur before anything else, as it enables all other functionality to occur. The next foundational user story is calibrating drone sensors for reliable and accurate data capturing, which enables the third user story, installing canopy cover measurement and tree health sensors on drones. Now, the first sprint is completed and testing can occur to determine data collection accuracy of tree health, canopy cover, and soil moisture, as confirmed by the arborist and tree maintenance team. The second sprint involves designing and mapping routine flight paths for each precinct. The fourth user story is necessary to proceed the drone control configuration, which includes automated schedules and manual override options for drone pilots. The second sprint will be tested by drone pilots to determine the effectiveness of the user story outputs. Here we have the sprint backlog in Jira. Also, we can see the Scrum board where the first user story item has begun, as it is in the In Progress column. The definition of done. When the drone developer discerns that the drone operating systems were configured to high-quality industry standards, one criterion is met for completion. Another criterion is when the arborist examines the tree health data and the maintenance worker examines soil moisture and canopy cover data collected, and they both find them highly accurate and relevant on 15 or more accounts, meeting predefined accuracy thresholds, then the sprint is done. Here we have the product roadmap, and as you can see, the first product backlog item, DDC, will begin on the 13th of October and finish by the 24th of November, in time for AMD to begin on the 25th. AMD will finish on the 6th of January, where version 1 will be completed. AWA will begin on the 7th of January before finishing on the 18th of February. PDV will then begin on the 19th of February, which is only one sprint instead of two, and will therefore finish on the 13th of March when the project will be completed. Sprint 1 aims to prepare the drones to collect data. Specifically, it will configure the drone operating systems, calibrate and install drone sensors. The three user stories should meet predefined high-quality standards on 100% of drones during testing. Furthermore, the daily Scrum meetings make the goal achievable, as we can all assist each other when necessary. The goal is highly relevant as the initial drone configurations, calibration, and installations are foundational to collect accurate and relevant tree health and maintenance data. Lastly, it's important to ensure the user stories are completed within the 3-week sprint. The Jira image on the right shows more details on the first user story. It highlights that Linux will be configured first before PX4 and Autopilot, and all of the operating systems will be configured through the GitHub software on a computer. This is the work breakdown structure on the left of Sprint 1 within DDC. Within the first user story, the first task is to install GitHub and configure operating systems with Linux. Then, configure operating systems with PX4 Autopilot before configuring the drone deploy in the third task. The second user story breaks down into the following tasks. Firstly, research and identify the required drone sensors to be calibrated. Then, calibrate drone sensors 2 drones at a time. The third user story has the first task to calibrate RGB cameras and IoT sensors for each drone 2 drones at a time to measure soil moisture and canopy size. Then, calibrate multispectral cameras for tree health detection 2 drones at a time. Thirdly, securely mount sensors onto drones 2 at a time. And lastly, connect the sensors to computers and the CSV file. Now, this risk assessment tracker highlights the following most critical tasks. For instance, a high risk is that the project could significantly exceed its intended budget. The mitigation plan is to carefully calculate the budget and set aside more funds than initially anticipated in case of unexpected costs. Also, it is important to clearly articulate and agree with all stakeholders on their roles and salaries with a legal contract. Another high risk is that the drones could severely malfunction and fall on a member of the public while flying. This risk would have high impact, but it is quite unlikely. Mitigation plans include to thoroughly test and regularly maintain all drones in case of any issues. Furthermore, it is important to ensure that the drone pilots are highly trained in manually intervening for the drone flight paths in case of a sudden drone malfunction. The third high risk is that the community and tourists may complain about the drones hovering over them. However, the mitigation plan is to encourage open community communication, such as through workshops and the news. Also, the drone monitoring process will occur at the same time daily, which eliminates spontaneous drone flying. These 3 highest risks are marked red in the risk quadrant. The rest of the risks are seen in the risk assessment tracker on the left. Here, we have the required resources and budget. The entire project is anticipated to have the budget of $1,287,412.78 for the first year. To break this down, the project salaries are estimated to cost $1,182,930 for the first year, when assuming the higher salary options presented in the table. However, since the project is not anticipating to run all year, some of the team will not be earning a full year's worth of income. For instance, the Scrum Master role will no longer be needed after the project's completion, and George can go back to his IT management role. Therefore, he will no longer be earning the Scrum Master salary. Similarly, the total equipment costs are $104,051.98 for the first year. This is expected to increase when factoring in drone maintenance costs for drone operation in the following years. Now, thank you so much for your time. I'm looking forward to working with you all, and I believe that together we can make this project succeed.